Okay. Now let's look at this problem. You have a 1 kilogram batch moving to the right horizontally and 20 meters per second. It's a 0.2 kilogram baseball sitting and rest on the post. The bat continues right at 5 meters per second after striking the ball. So initially the batch M1 equals to 1 kilogram moving to the right with V1 equals to 20 meters per second. Okay? And there is a baseball with M2 equals to 0.2 kilogram. Okay. After the bat strikes the ball, what happens is the bat will still move to the right with velocity 5 meters per second. And of course, the ball will move to the right with some unknown velocity. So let's call the two velocity U1 and U2. U2, the final velocity of the baseball is quantity we want to find. Okay? So here, for this problem, it's a collision process. So for collision process, there is something we can always use, some equation we can always use. Which one? Okay, that's what we talked about last class, at the end of last class. Okay, for collision and explosion process. Conservation of the momentum. Okay, so the initial momentum equals to the final momentum. For any collision and explosion process, you can always use the momentum conservation.
Is that x2? Oh, that the ball like moving to the right?
Newton.
What? That's U1, U2.
Oh, U1.
Okay? We usually use V for the initial velocity in this part, and U for the final velocity. Okay. Now, this is a two-body collision, so P naught will contain two terms, which is M1 V1 plus M2 V2, right? This is the initial momentum of the bat. This is the initial momentum of the baseball. And then the final momentum can be written as M1 U1 plus M2 U2, right? This is the final momentum of the baseball. This is the final momentum of the ball. This is the final momentum of the bat. This is the final momentum of the ball. Okay? So here, in this term, it contains U2. So you can get U2 from this term. You need to know all other quantities. We know all other quantities. V1. What is V2?
0.
0. And U1. So we know the three terms. We can calculate this unknown term. If you put numbers, so 1 multiplied by 20 plus 0.2 multiplied by 0, so actually a 0 term, equals to 1 multiplied by 5 plus 0.2 multiplied by U2. So this will give you U2. What is U2 here? Okay, 75 meters per second. So that's the final velocity of the baseball. Okay? Any question here? So the momentum is conserved during the collision process. And then we want to calculate the total kinetic energy change during the collision. Okay? And so let's check how can we calculate the total kinetic energy change. By the way, this kind of indicates us that in this collision process, the kinetic energy is not conserved. Okay? The momentum is conserved. So kinetic energy change, again, we can use the definition. delta K, the change in the kinetic energy, can always be calculated from the final kinetic energy subtract the initial kinetic energy. Okay? So final kinetic energy contains two terms, 1/2 mu1 squared plus 1/2 m1u1 squared m2u2 squared. Subtract the initial kinetic energy also contains two terms in general, 1/2 m1v1 squared plus 1/2 m2v2 squared. Okay? So, as a little practice, so can you tell me what's the meaning of this term? Okay. In words, what's the meaning of 1/2 m1u1 squared?
Potential or kinetic energy.
Kinetic energy of what? Before or after the collision? After collision. Okay, so that's the final kinetic energy for the batch. Okay. Similarly, what is this term? It's just random figures.
The ball is found. The ball is found.
This one?
Initial.
Zero.
I mean, don't tell me what is the number. Tell me in words what it is. Kinetic energy for the ball. Initial. So initial kinetic energy for the ball. Okay. So when you write down all these equations, I hope you do this practice. State the meaning of each term with words. Okay. So you know what exactly you are doing here. Okay? That's the best way to understand each calculation here. Now, so then you just need to substitute the number to get the answer. Here, V2 equals to 0, so this term goes to 0. So you get 1/2 multiplied by 1 multiplied by U1 is 5 squared plus 1/2 multiplied by 0.2 multiplied by U2, okay, minus 1/2 multiplied by 0.2 of 1, and 1 is 1, multiplied by V1 is 20 squared. Okay. So, this is the kinetic energy change for the process. So you can get some number in Joule. Okay. Now, here, if you remember, we have the previous example for 10.1. Is to calculate the force exerted by the batch to a baseball. Okay. To calculate the force, we use F average multiplied by delta T equals to delta T. And we apply this to the baseball. Okay? And you can see here, when we apply the two different equations, the impulse momentum theorem and the conservation of the momentum. Can you see there is a big difference? How can we apply the two equations? This one is applied to the whole system, right? In this equation, you have two terms each side. One term is for batch, another term is for the bore. And for this one, if you want to calculate the force, when you calculate the momentum change, it's for just one of the objects. Okay, if you go back to check, we apply this equation for only for the baseball, and we don't consider the bat. Okay. So you can see usually that's what's going on. If you have a system include like contain two objects, so the momentum conservation is for the whole system. And for each of the objects, in fact, use the in-house momentum theorem for each of the 1 and 2 separately. Okay. So the momentum conservation kind of put them together so you can bypass the calculation of the force. Okay? Any question here? So please note the difference between the two problems. Now,